In this episode, we want to walk through the Pandas library. And the first thing first is to install the Pandas, pip install Pandas. We can write import Pandas as PD. So I can say PD and underline version. So I should be able to see the Pandas version, which is 1.2.3. Another command for version, we can use pd.show versions. You can see here, Pandas is running on that version, but using a NumPy because one of the requirements of Pandas is the NumPy library, and also it uses a date util for handling the date. Has some PyTest, Cython, and XLRD for the Excel, and Xarray also, and tabulate data for CSV, and there are some dependencies. Pandas is the best way in Python to working with the data frame and series. And to giving you an example, suppose that we have a dictionary in Python. We have animal, and those animal are like cat, dog, and snake. And so we can have another key life expectancy. Okay, and suppose the cat is like 10 years, the dog is 15 years, and the snake, I don't know, is like maybe 8. Just pass the A to the data frame, and it will create for us a data frame. I call it DF. And by that, I can show you what is inside the data frame. So you can see there is 3, the animal and life expectancy, which is cat is 10, dog is 15, and a snake is 8, as we defined here. Suppose that these data frame has lots of rows, and we just want to see like first 10 row, first in this example, first 2 rows. So I write head, and I can pass how many first rows I want to see. And you see, I just type 2 here. So the head command showing the first n rows of the pandas. So in data frame that we have created, we can see the D types. The D types is the types of each column. So the animal is object, and the life expectancy is in 64. The best way to save a pandas data frame is to define the D types. It means that if we know the D types, it's better to change them to something that takes less memory. What we can do is we can say df as type, and we set the type. We can pass a dictionary with the column name. So this column name is the animal. We can say the animal is like str. There is another command. We can say df memory usage. Let's see. So it said that the memory usage is like index is taking 128, animal is 24, and life expectancy is 24. If I do that and I do the memory usage again, so it's same. I just put the 0.5 here to change this. So if I assign this as type to another data frame, so the new data frame is, if I see the D types, remember that it was float, so the new one is in 32. And if I see the memory usage of this one, it is 164, a little smaller than this. It is a good practice to always check the types of each column and try to reduce them as much as possible, because when your data frame is big, it is harder to manage and applying some operation to it. So we can do commands like df-info, which give us the info of the data frame. Like we have 3 non-null. The first one is the object. The second one is the float 64. If I run this and do the info, so it would be in 64. Besides df-info, we have df-describe. So we can get a description of what's going on here. Like what is the count, what is the average, what is the standard deviation minimum, the 25%, the 50 and 75%, and the max. Okay, so like NumPy, we can access to each row and column of data frame. Suppose it is a matrix. So we can say df iLook, the first index is the rows and the second is the column. And we can pass any numbers. Like I can say, I want to get from first row to number 2. Okay. So if I do something like that, so I will get from, it is equivalent to when I use df.head by 2. And if I want to just get the second column, I can say, I just want to see the second column. And in that case, I will lose the column name because passing the exact position of one column. And it say the name of the column is here. So let me put this in a variable. I call it PS. Just want to show you what is this. It is somehow different than the previous output we could see here. So if I say what is type of PS, it say it is a series. But if I say what is the type of DF, it is a Pandas data frame. So it means that any data frame with one column is a series. It can be a time series, it can be a series of text. But when we say I just want to have one column, automatically cast the type to series. Beside iLook, we can use look. And with look, we can say the name of the column that we want. So for example, I wanna, what was the name, like life expectancy? I wanna get the life expectancy column. And if I do that, I say none of the index are in the index. So we need to pass an index too. So I need to pass the index. And maybe I can say 0 and 1 and the life expectancy. So it's returning me the 0 and 1 life expectancy. And the difference here with this is a data, this is a series, but this is a data frame. If I say I want only the first index, I get the first index. And still, this is a data frame. So suppose I say I want to get animals that have life expectancy more than 9 years. So in that case, I can say I want a life expectancy more than 9. I get a mask. You can see the first one is true, second one is true, and the last one is false, which is correct. But we want to get a data frame with that. So we can just pass the mask and we get first and second. Similarly, if I say I want a log of this, I'm getting the same result. The default indexing in the pandas work based on .log. So if you ignore writing .log, it assumes that your purpose is .log. We can make it more complex, like I want to get DF that has life expectancy bigger than 9 and you know, that was a mask and we can apply an and to the mask. So maybe I can say have a life expectancy less than 15. So in operator priority, we have the and in Python has higher priority than others. So it will and this one with this one, which is not making sense. So what we need to do is we say the priority by parentheses and say, first do this, find the mask, second do this, find another mask and add them. And this is the result. So the cat is the only animal that has life expectancy between 9 and 15, for example. So instead of doing this, we can say DF and for life expectancy, which is between, I can say between, and like between 9 and 15. If I do this, it will show me the mask. But the right is inclusive, so it is somehow different than this because in this case, we haven't included the 15, so I can, if I run it, the dog also will be included. But in this case, if I use between, the right one is already included, but I can write inclusive is equal to false, which means the right one is not inclusive, and I just get the first one. Then similarly, I can say I want to apply this mask on this data frame. So I will get similar result when I saying I want to get between 9 and 15 of life expectancy. We can also do some mathematical operation like I want to apply sum on this column. So I can do it. I can apply like a mean on this column. Okay, suppose I want to add another column. I can say df and name of the column, like I want to add, what can we add? We have the animal, we have the life expectancy, and we can say they are domestic or non-domestic, something like that, or they are dangerous or non-dangerous, something like that. So you can say type, the name of the column, and we have 3 rows. That's why we need 3 rows for this column. I can say the first animal is cat, which is non-dangerous, the dog is non-dangerous, and the snake is dangerous. And if I do that and I see the data frame again, what I will have is another column that is added here. If I want to have another column and I only pass 2 variables to it, okay, like this, I will get an error because it said the length of value does not match the length of index. And if you don't have a variable, you can just pass np.nan or something like that, that it will be a nan value there, okay? And okay, let's back to our example. So we have non-dangerous and dangerous. So we can group the animals using group by method. Suppose they asked us to calculate an average life expectancy of non-dangerous animal. Okay, we want to have a group by. So I say group by, and by what? I want to group it based on their type. So it will return us, if I just do this, it will return us 2 groups. First, including a data frame of this, and the second is including a data frame of this. And I want to say for each group, for example, I want to get the life expectancy and I want to get the average. Okay, if I do that, I will get 2 groups, okay, the dangerous and non-dangerous, because the group by is applied on both. So it will show us the non-dangerous is living more than dangerous ones, okay? There is another command called value counts. We can count how many, for example, how many non-dangerous animal we have in the data frame and how many dangerous. So I can say df, and I want to count based on the type, I can say value counts, okay? If I do that, it show me we have 2 non-dangerous rows and 1 dangerous rows. I want to add another column, number of children. I mean, in each time delivery, how many children they deliver. For example, for a cat, it can be like, I'm just supposing 6, and dog is like 3 or 4, and a snake is 1. I don't know, maybe 2. Okay, and if I do that, I will get another data frame. And suppose we want to sort this data frame based on their number of children. And after that, sort based on their life expectancy. So it should be, this is the first priority, and after that, this is the second priority. What we can do is there is a sort values. So we can say sort values. We want to sort based on index. We want to sort based on the values here. And sort by values is getting, if you see, there is a by, and you can pass how many column we want. As I said, the number of children is the first column I want to sort based on that, and the life expectancy is the second. If I do it, you can see I'm getting based on number of children based on life expectancy. If I say I want to sort ascending based on number of children, but descending based on life expectancy, I can also do that. I can say ascending for the first one is true, but for the second one is false, which means that for life expectancy, I want to have descending order. So if I change, for example, this is again 6, just giving an example, and I run it, so it's show me this is ascending and this is descending. But if I remove this and make it true, so there is no change here because both are 6, but here we ask for ascending order. That's why it's pick this one. Okay, let's go to another example. For example, I just want to put ND here instead of non-dangerous and D instead of dangerous, instead of having a big name here. What I can say is I want to map, and what map I want to create is for which column first. For type, I want to do this mapping between the non-dangerous, which should be what? Which should be like ND, and for dangerous, it should be D. Okay. If I do this, you will see this is the column, and it means that I have to put it in the same column because it's not changing the df, you know, it is same. So if I want to overwrite, I just overwrite the column using this command. So and now if I show the df, so you see that everything here is changed. Okay, so we can map a name or even a number. And if you don't want to map like this, we can also use replace. The replace is like, we can say replace everything in what column? Everything in type column. Replace everything as ND to ND. Okay. If I do something like that, so it will replace for us. And again, I can overwrite that column. So you see that everything is changed. The ND is now converted to ND. The map can handle multiple things, but replace is usually for replacing a text with another text. So if you want to create a pivot table, pivot tables means that, for example, I want to change this table to another table that is showing some information that I'm interested in. Like the type of the animal is the index. So we have just 2, like the dangerous or non-dangerous. So there are only 2 rows in that new table. And the column is the name of the animal, for example. And for each value in that table, we want to show, for example, number of children or life expectancy. So what we can do is we can say df pivot table is getting an index, getting a value. So what values pivot tables? As I said, we can say life expectancy, we want to have it in the values. And it said, what is the index? Index is the type. I want to have rows, just 2 rows, dangerous or non-dangerous. And what else it needs is we need a columns. So the columns is, I just want to have one column like animal. Okay. So if I do this, you will get a new table. It's showing that we have dangerous and non-dangerous group. And for dangerous, we have this animal, and each value is here is a life expectancy. Okay. Now we can go to some beyond the basics example. I want to add another row. For adding a row, I can say df.append. It can be another data frame with the same name, or it can be, let me show you. So we can have this dictionary that we had before and create another data frame here. Okay. And we call it data frame 1, and we want to append this data frame 1 with our data frame. If I do this, you will see that things are repeated, and for 2 columns that we hadn't add any value there, it automatically filled it by NaN. And you see the index is again repeating. So we don't want to have an index repeating. So in that case, we can create index, unique index here, or we can say ignore index ignore index equal to true, in that case, it will create the ascending order index. Suppose that we have this data frame and we want to remove that has same animal name, okay? One of the command we can use is, we can say drop duplicates. By drop duplicates, it asks us what subset. It means which column we wanna do the duplication check. Okay, when we do the drop duplicates, it keep the first, but if the rows here come up and we keep the first, so we will lose some information. We wanna apply the unique, but we also wanna remove every row that has nan in it. What we can do with the nan? So with this df2, there is a function, it's called isNull. If I do, it will show me a mask showing which column, which point of the data frame is null. And if I apply a sum, show me that the type has 3 null, number of children has also 3 none. We can have drop nan or drop na, which remove the nan. And if we do this, it will remove the rows that are nan. So it is a good practice that if you want to apply a duplicate and we are not sure about the data, that there are some nan in there, it's better to apply drop nan or drop na, and after that apply drop duplicate. Okay, and also be careful about these methods, that when you apply them, to be sure that is there any in place, like in place is equal to true. In that case, dropping is really applied inside the df2 and you don't need to copy to another variable, and it's assumed to be faster. You can always switch between the pandas and numpy. Like we have this data frame and I want to switch it to the numpy, so I can say values, okay? And these values is the numpy array. If I see the type of this, it is a numpy array. So we can do all operation that we applied on the pandas if we get the values. But in most of the cases, we can do many operation using the pandas function. Like, for example, suppose df is a data frame, a pd.data frame, and it's created by, let me import the numpy, import numpy as np. And here I can say np.random like random. I can pass a size, I say 5 by 3. So if I create a matrix like this, it would be a data frame, and I can apply many things here. Like suppose we want to subtract the row mean from each element in the row. In that case, we want to calculate the mean, but we need to pass axes. So I want to calculate the average. If I pass 1, it will show me the average in each row. You can say df.sub, there is a subtract method. And with the subtract, we also want to have access 0 because we want to apply it on each row. Okay, this is our data frame, and we want to see what is IDX max and IDX min. Well, let me just print the df just to be sure that everything is okay. This is the data frame, and this is the IDX max. So it's showing for this column, the 0, 1, 2, 3 is the max, this is the max, and this is the max, okay? We can apply it like using axis 1, which is applied on each column. So it say that for this row, which column is the smallest index? So this is the smallest index, number 2. And for this one, this is the smallest index, okay? Let's go to another example. In Pandas, there is also another thing we can call Enlarges. So we can say Enlarges, like 3 largest. And we need the columns, and we need to say which column we are looking to. So I can say columns 1. So for 1, find the n largest rows. Okay. So the first one is this, and the second one is this one, and third one is this one. So you can see that we can get the n largest. And if we want to have just on this column, so we can say on column 1, you can say for this column, give me the first largest value, which is this one, this one, this one, and it is correct. Okay, let's jump to another example. Consider we have a data frame, something like this. So it is based on the random function. Let me show you. So we have random function here, random state means that we are creating based on the random states. So every time we run it, it will not lose the seed. And we just create a rand int between 1 and 101 in size of 8 by 8. Suppose we want to get a list which has the column index and row index of n largest value from this matrix. Okay, so we want to get the n, for example, 3 largest item, but we just show them by the number of column and row. So for example, number 5 and 7, so it is 5 and 7, which is this, is the largest, should be the first. And what we expect is we get something like, as I said, 5, 7. And if I want a 3 largest, for example, the next one should be the number 6 and 4. And the next one is number 2 and 4, 5, okay? I want to apply some operation to get this. How can I get the n largest without losing the position? There is a method called onStack. If I print df just to see the df, so it means first column and first row is 38, second row is 18. You can see here. So we are doing onStack. onStack means that we put every column here in one stack. Okay. If we apply a sort values on this, so what we want to get is we want to get the from -3 to end. We want to get that. So we will get these 3. Okay. But we want to have it in the list, something like this. We just want to index it. So this is what I can show you. This is a Pandas series. And for series, we can access to the indexes. So we can say n largest index. And index is showing us this, but we need the values of that, okay? So this is an array that we want 5, 7, 6, 4, and 2, 5. That's it. And if you want to convert it to list, instead of values here, we can say, I guess, to list, and it should work. Yeah. Let's jump to another example. Suppose we have a data frame like this, and let me show you how it looks like. And we have some data here which needs to be cleaned. This is something that we usually face when we are solving a machine learning or data science problem. What we want to do for cleaning this is, for example, some value in the flight number are missing. So we can use some imputation algorithm, but suppose that we want to do some imputation that we have figured it out. For example, you can see there is 45, 65, 85. It means maybe if I add just 10 here and add 10 here and put it here, so I will create a flight number, maybe. I'm just speculating. So if write something like flight number, I want to interpolate it. And if you do this interpolation, you can see here, and I want to say set type as int, okay? Because I don't want to float here. And I put it back to the data frame flight number. So if I do this and I show you the data frame again, so you can see everything seems okay, and we filled some of the nets. This is one part. Another thing that we have here is, so we have a column called from to. It said London, Paris, and it seems that it can be separated like from London to Paris, from Madrid to Milan. So we can separate this column in two columns. We can get the values inside the from to just by running this. And for getting the str values, I can say split, because I'm supposing this is a string, and I say split it based on the underline, I guess. Yeah. And we can set a temporary variable here. And let's see what we have in the temporary variable. In temporary variable, we have London, Paris, Madrid, Milan. With this split, we can also pass expand method. In that case, if I see the type of temp, now it is a data frame. And if I see the temp, I will see these are in two different columns, okay? Now I can name this column. I can say columns, and the first is from, and second is to. I want to merge this to our data frame. That means that we want to add more columns, yeah? But we have two data frame. We want to concat temp and df. Maybe it's better to have pd here. And I want to say we want to have it in axis 1, which means we want to have it in, column concatenation. So if I do this, I will have from to, I can now remove this column. For removing a column, I can call delete, and let's set a name for it. We can say delete df2 and the name of the column. Okay. And if I show you the df2, now it is just from to flight number, recent delays, and airline. So we learn how to concat two data frames by their columns, and also we learn how to delete a column and how to split a column. So if you see this data, you see some of the text is capitalized, some of them are not. So when we are doing the str split, here we can apply capitalize. So for this purpose, what we can do is we can say capitalize, okay? And do the same thing for to. If we do this, we can see that the text is now okay. We capitalize everything, and if there are any other words is capital, it's now lowercase. Besides of deleting using this method, we can use a drop, and I say df.drop, and this is df2, and we can say which column we want to drop, and the column we want to drop is from to. The thing is, if I apply this, say not found in axis, because we have to say it is one column. So I set 1, and the df2 is drop, but it is not in place, okay? So I can say in place is true. Instead of doing this concatenation also, I'm just trying different ways of doing stuff. You can say df2.join. You want to join two tables, and joins with what? With temp. And it will, join means we have a concatenation on axis 1. It is in its definition. And if we do this, we will get exactly similar. But we are saying the df is first, and after that we have a from to. In the previous example, we have temp first. So it is important that which one is first. And also there are some, I think, parameters we can pass. Let's say which one is right, or join from left, join from right, something like that. So if you want to do vice versa, so we can say temp and df. Okay, it's exactly same as this one. So another cleaning we can do is, we can see there are some exclamation mark, some extra punctuation. So we want to remove all of these and make it cleaner. I can say df2 and I want an airline and I want a text of it. And there is a method called extract, and extract, we can pass a regular expression, and by regular expression, I can say remove everything like parentheses, like brackets, and everything should be A to Z, okay? Should be A to Z and A to Z, and everything should be S, a string. And everything should be a string. And I don't want to go inside the regular expression. I'm not the expert in regular expression, but for cleaning text, you can use this. And after extracting, we don't want to have expand true, we want to have expand false, because we don't want to have all data frame. We want to just have this column and copy everything again on this column. And because this is just a series, we can apply again str. And I want to have a strip, means removing the space. So if you see now, the airline is now really good. Another thing that we can do is we want to make n column based on how many items are in the list. Like here, there is 3. So instead of recent delays in one column, we want to have delay number 1, delay number 2, delay number 3. What we can do is we can say apply, and we can say applies a series. So what we are really doing when we use apply function. Let's give you an example before going further. So I can write a function like custom function, okay? And the custom function is defined here, def custom. And I get the value here. And I say print the value, just for showing you how this is working. If I run this, ignore this part because it's returning none from the function, but it means that for every row of the recent delays, we are applying a custom function to it. So for example, I can say here, I want to print the type, or like something else, like I want to have non-mean, okay? If I do this, so I'm calculating the average, like in here, 23, 47. So apply is a good method when we want to apply something to each row data frame. If I apply something like pd.series on a list like 2, 3, 4, or 5, okay? And ignore this part. If I apply this, it will create 3 different rows for me. If you apply it on each row, it means that we are making series and concatenating those series, or better say, appending those series together to create a data frame. So in that case, it means that if I have this and I say for each rows, I want to have a series, it will return us these values. This is the first series, this is the second series, and all of them are appended to create a data frame. I like to change the name. I can say this is our temp now. I want to change the temp columns name to, so I don't know how many columns it has, but I can write something like for C in temp.columns. Okay, you can write something like, it was number of delay, yeah? So I can say delay number and C, okay? If I do something like this, what I will get by temp is delay 0, delay 1, delay 2. So similarly, I have df here. I can say drop, like here. I can say drop the recent delays by axis 1. I don't want to have in place, because if I do in place, it's inside the df2, and I cannot use join here. I cannot use any function here. Okay, I can say now join with the temp. So you can see that we have from to flight number airline delays, and Other things we can do is like df, I can say fill now, and yeah, you can see that data is now really clean. Let's see what else we can do with Pandas. Pandas is using Matplotlib library, and we can use Matplotlib functions for plotting. So we can write like df plot, and you will see that we have like bar plot, box plot, density plot, different kinds of plot that we usually have in Matplotlib. For example, I can say I want to have a scatter plot, like the flight number and the delay. So I can say flight number is the x-axis and the y-axis is the delay 0, the name of the column. And if I run this, it will show me the flight number and we have number of delays, so we can have a visualization. Instead of this, I can use bar. One of the other things that Pandas is really good in it is loading the data. So I can read CSV file, and you can pass a CSV file here and load the data into a data frame, or it can be Excel sheet. And by loading an Excel sheet, we can also pass the sheet name. So if there is a sheet name, we can say which sheet we want to load in the data frame. There are other libraries like data table that are usually faster in loading CSV files. So if you have a big CSV file, I recommend to use data table instead of using the Pandas. You can also use read SQL, read from a JSON file, read pickle file, read JSON, and read the table. So different kind of things that we can do in the Pandas. I have here an Excel sheet, and I want to show you how can I load it. So I can write pd.read Excel and name of the file. And if I load that, it will load the Excel sheet for me. And as I said, we can write something like head 5 to just see first 5 rows. And this Excel sheet includes some features of leaf. For example, we have different type of trees and some features of the leaf. I don't want to go to the details, but I want to show you some example here. So this is our DF now. And let's see what D types we do have. And what I want to do is change this to use less memory. Currently, if I see the memory usage for each row, for the tree, I'm getting 8,592. I can change the tree as type and change that to category. Okay, so there is a type called category. So I can print the memory usage, and after I change the type, I can print the memory usage again. Write the total memory usage here and total memory usage here. So I could reduce the memory a little if I do genotype conversion and set the type as category. And let's see if I don't have these, I want to show you. So in some cases, you can see that after I set the category of genotype to type of category, it's getting more memory. Why this can happen? What is the shape of the data frame? It is 1074. And from 1074, when we do the change type, the genotype to category, you will create 358 different categories, which is huge because instead of saving a text, we are saving text and also saving the quotes. So I can say, for example, if I say values.quotes, I will get the quotes. So it's somehow converted to some quotes. And I also can get categories. So in that case, quote 0, it means boy 1. When we say quote 1, it means boy 10, something like that. Sometimes category is making sense. And converting a column to the category format use less memory. Okay, we try to cover some of the important aspects of working with pandas. Of course, I recommend you to see the documentation, the part about time series, and also for improving the performance using Dask libraries or other type of libraries. I mentioned one of them, data table, but still there are many things to read, like using the agreement function in combination with group. So when we group by column, we can use agreement function to agreement some of the computation and create a new column, or using a resample function, using a filter function. So there are still something in the document, but I guess I could cover at least 50% of the documentation that you can now jump on documentation and understand what's going on. Your comments and your subscription will inspire me to make more videos and understand that I'm creating good content or not. So please follow, subscribe, and leave a comment. Thank you.